Okay, welcome back. This is Mr. Francois. We are talking about describing circuit connections today, and it can be a little bit problematic. So let's start off with one of the most basic ones, series. Now, series, by definition, is all current that enters one component must come from the second component, and all component that leaves the second component must go through the first. So what does this mean? It means that the current that enters our resistor 1 here, here's resistor 2, so the current that enters into 1, that flows out of it, must flow into resistor 2. And not only that, all the current that goes into resistor 2 must have come only from 1. If it can come from any other source, then it's not series. Or if it can go to any other source, then it is not series. So let's take a look at a couple more examples. We have two circuits here, and the first one that we want to take a look at is going to be the one that's on the left. This one has 4 resistors in it. You can see how it is arranged here. And what you want to do is you want to identify what flows directly into what. Now if we take a look at it, of course our current comes out of the positive side of the battery and flows this way. And then our current goes down, goes through resistor 1, goes through resistor 2, flows over here, and then we have it splitting up. 1 goes through 4, and 1 goes through 3, before meeting back up on the other side, and going into the battery once more. Now, if we look at this, we can see clearly that resistor 1 and resistor 2 are in series. The current that goes out of resistor 1 goes directly into resistor 2. There's no possibility for it to split up or go somewhere else. That is the only place that it can go. Now, if we look over here at our second setup, there is actually 2 series in here, one of which may be a little bit apparent to us. Resistor 3 and resistor 4 here are in series, and that's because even though they are part of some random junction that we haven't really talked about yet, they still have the current flowing from whatever goes into 3 must go into 4, right? So that makes it series. Now, there's also another one, as I said, and a lot of people may not see this one. If we look at resistor 1 here and resistor 5, these are also in series, and this is because all of the current that goes up into resistor 1, even though it splits up so that some of it goes through resistor 2 and some of it goes through resistors 3 and 4, it comes back together, and all of that current, we're not using it up, it doesn't magically go away, it comes back and it goes into resistor 5. So that's what makes it series, because all the currents that ended up going into 1 ended up going into resistor 5, and everything from 5 came from resistor 1. It does not need to be an immediate thing. Okay, there can be different components in the way, as long as every amount of current that went through resistor 1 must go through resistor 5, and there's no possible way of there being any diversions. Okay, so even if it splits up, as long as it comes back together, after that point, anything that's on that line should still be in series with it. Now, what is our secondary thing? How do we call these little branching parts right here? Well, we go over and we call these things parallels. Now, parallels are the current that flows through the first component cannot flow through the second component, and what flows through the second component cannot flow through the first. So what does this mean? Well, our current that comes into our parallel here, it splits up, just like I've shown you in the other diagrams, and one of it goes to the left side, and we'll call this resistor L, so the left resistor, and we'll call this resistor R for the right resistor. And so if we look at the current that comes in, it splits up, and some of that current goes into L, and some of that current goes into R. Now, if we look at this, the current can only go those ways, and then they meet back up over on this side, and they continue flowing on down through. This is what a parallel is that the current splits up and it goes to one or the other. It cannot go to both. So if one comes before the other, or it comes after the other, it's probably not going to be a parallel. Okay, it may look like one's coming before the other, but as long as the current divides and it doesn't come back together until afterwards, then it's probably a parallel. All the current that goes through L cannot go through R, and all the current that goes through R cannot have possibly gone through L. So let's see another example of this. If we look here at our left diagram, what we see here is a fairly complex circuit. We see a couple different things. We see a series from before with the 6th resistor and the 1st resistor, but that's not what we're trying to talk about right now. We're trying to talk about parallel. So there should be something that is in parallel with the next. And so if we look at resistor 4 and we look at resistor 5, we'll see that they are in fact in parallel. However, even though I know that a lot of you will be tempted to say this, resistor 2 is not in parallel with 4 and 5. Because why? Why is it not in parallel? Well, I mean, it sort of is. However, it has another component on it. It's attached to another thing. Okay, so that current also goes through there, so we can't really call it parallel. Our definition of parallel isn't really complete per se, unless we talk about branches. Branches are really the thing that are parallel. So this entire branch, the branch that has resistor 5 on it, and this entire branch, the branch that has resistor 4 on it, are in parallel with one another. And the branch that has 2 and 3 on it is in parallel with 4 and 5, but resistor 2 is not in parallel with resistor 4 or resistor 5. Okay? So only 4 and 5 are what is in parallel in this case. Now, if we look over at our right diagram, we see that there is another way that you can look at parallels. It doesn't need to be side by side like that. As long as it splits up like it does right here, one side goes this way, one side goes this way. It's a little bit unorthodox, but occasionally you do see them like this. Okay? So you see how it splits up and it comes back together before going into here, and there's no other components on there. So it's not like 2 and 3 from the other side. There is nothing that's extra on the our one side, nor is there anything extra on our 2 side. Okay? So let's get a little bit of practice in. Let's see what this actually looks like. So if we look at these 2 complex diagrams, clearly we have a lot more resistors in here. What can we say about the individual resistors? Not the branches, just the resistors. What things are in parallel, what things are in series. So take a second, stop the video right now, and then try this out. See if you can figure out what it is that is in series or parallel. So stop the video. Okay, and now you're back. You should have tried this out. And what you should have identified is that R1 here and R4 are in series with one another because the current that goes through 1 all must go into 4, and everything from 4 comes from 1. So 1 and 4 are in series. And what you should have seen as well is that R2 and R3 are in parallel. So we can label these R2 and R3 parallel. Okay, on the other side, on our right-hand one, what we see here is a couple different kind of daisy chaining effects. What I first noticed, and I hope that you did too, is this line right here. What you should see is that all 3 of those are kind of all just stuck together, and they flow from one into the next, with no break either. So this means that they should automatically be series. So R2, 3, and 4 are a series with all of each other. So 2 is in series with 4, 3 is in series with 4, and 3 and 4 are all in series. Okay? 2 is in series with 3. There we go. That was the last combination I was looking for. And another thing that you could notice is that this line right here, R5 and R6, flow into one another. And so that means that R5 and R6 are series as well. However, and I know a lot of people would be tempted to say this, R2 and R5 are not a parallel, okay? They have other components on that branch, so we cannot say that they themselves are in parallel. Everything else also kind of adds in. But we can say that 7 and 8 are in fact in parallel. So R7 and R8 are in parallel. Okay, so this has been your quick little tutorial on how to identify connections in complex diagrams. The other connections that are in here, we cannot say anything about. They are neither series nor parallel, and clearly you cannot be both. Series being all of the current goes from one into the other, and parallel being none of the current goes from one into the other. So I hope this has clarified things a little bit for you. Please feel free to leave a comment if you have any suggestions, and see you next time.